Good afternoon to all of you, and today we will talk about glacier inventory. Uh, so, so that how glacier inventory is done, what are its parameters, what are the different types of inventory there, and you will also realize that there is a lot of difference as we move from one glacier into another glacier, not in terms of only number of glaciers, but also in terms of aerial extent of glacier. So if you take any inventory, you will find there are the number which is given for in India is a different. It is given by through inventory, which is if you take RGI inventory, if you take GSI inventory, there will be a lot of variation, and why those variations are there, and we will try and explain two things. So, but let us first understand what is glacier inventory. We will come to that, but let us recap what we have seen yesterday or day before yesterday. This is how glacier looks like. Idea of a glacier inventory is to prepare a map of this, and then identify that glacier. That's the idea. So this is how glaciers will look like. Yesterday, we have already seen some of these this figure in depth, and we know that there's the accumulation area, a glacier, which is snow, where the seasonal snow remains throughout the year, and it is accumulation area, and an ablation area of a region where there is glacier ice is exposed during the summertime. And the line separating between the accumulation area and ablation area is the equilibrium line. And within that, there are numerous zones: dry zone, percolation zone, wet snow zone, and the ablation zone. So some of these can be mapped by using remote sensing technique. Not all of them can be mapped by the technique. And another, some of you have also raised the idea about the bottom of the temperate glacier. And you know that one of the key things to understand is bottom of the temperate glacier is always liquid, essentially because as pressure increases, the melting point of ice reduces. It becomes more and more negative. And since it is become more and more negative, as glaciers move, because of friction, some energy is generated at the bottom, and then that energy cannot dissipate upward, and because of that, there is a reverse temperature trap causing liquid at the bottom of the glacier. In addition to that, we can also see here that the movement of glacier ice is not parallel to the surface, but in accumulation zone, it has a component which is the submerging component. It is the downward, and as you come into the ablation area, it is emerging component. That means it is coming a little bit upward. And that is creating numerous depressions inside the glaciers, and sometimes it leads towards the formation of glacier lakes. That is what we have seen. We have also seen that if you want to apply glaciers or you want to map glaciers by using remote sensing technique, there are certain things we can map, like glacier boundary, we can map, we can snow and ice, then the reflectance and albedo, glacier terminus, glacier advance, retreat, and area loss, supra and pro-glacier water bodies, moraine active and inactive, moraine's velocity, depth, and glacier mass balance. These are the features we can map by glacier by using remote sensing technique. However, when it comes to the inventory, it is not necessary that all those features can come into that. So some of these glacier features, you can see how they look like on the map. We have looked into detail this today, so we may not we may not like to dwell on that. But let us look into the what is glacier inventory is all about. Glacier inventory is a detailed compilation of topographical and morphometric data of individual glaciers. Uh, and this includes location, size, elevation aspect, and other glaciological data. But over a period of time, uh, I know that there are many things have happened, and some of these things are not in a glacial inventory. Like there are multiple layers, multiple years glacial boundary layer has been prepared. So it is possible for you to have how much loss in area, loss in retreat of glaciers. There is also on larger scale geodetic mass balance is done. So it is also possible to incorporate that, but that is not something which is done traditionally when you do the glacier. There are numerous agencies which have done the glacier inventory in the Himalayas. And the earliest one, glacier inventory, was done by Geological Survey of India. So that inventory was started in early 80s, and GSI done this inventory predominantly using the topographic map and sometime aerial photographs. And the later part, they have used the satellite images as well. We will discuss about this glacier inventory, but this inventory is not available in the form of a digital form. It is only available in the book form. Therefore, this is not extensively used, but still you can use as a reference material if at all you want to, know how glaciers have changed. A fairly decent job has been done by Geological Survey of India. Therefore, it is worth referring all the time. There is also inventory done by Space Application Center, which is a part of India's Space Research Organization. And there are multiple inventories ISRO has done, but one of the inventory where mapping is done on a basins level, that means Indus, Ganga, and Brahmaputra. These three basins were selected and inventory done. And Geological Survey of India has done inventory only in India. It means that large part of basins are not done by GSI, and that could be another limitations of that. Then there is also Randolph Glacier Inventory, which is popularly known as RGI. One of the beauty of this inventory, like previous two inventories, this inventory is available in digital form. And anyone can download that inventory. You can just Google it and you will get the addresses and how to download that inventory. And this is very popular inventory which people have used. But even though Space Application Center inventory is in digital form, but that is not easily available. I don't know. There was attempt to put it on Bhuvan or some other website, but you have to check whether currently available or not. But Randolph inventory, RGI inventory is available and you can download it. So this is one which is popularly used. And one of the reasons why this is popularly used because this work is done voluntarily by a large number of scientists working in the field of inventory. It was originally done for when the last IPCC report was prepared to assess how much is glacial store water outside the polar region. for that purpose, but this is a predominantly voluntary effort by a large number of scientists. Therefore, the scientists who have contributed in it continue to use it. Therefore, it is very popular. There is also one inventory, which is the glacier area mapping for Asian high mountain GAMDAM. This is also a inventory which is available for Asian high mountain, and we'll look into that, and you can also download it. And there is also International Center for Integrated Mountain Development, EC mode, has also done inventory, and you can also look into those inventory. Probably you can download that inventory from EC. So let us look into the Geological Survey of India. One of the key things when you look into this inventory is how do you identify the glacier number? So it is very tricky issue to identify because there are thousands and thousands of glaciers. So this is grouped into two. It is a global inventory. It is originally done for UNESCO and temporary secretariat for glaciers. Inventory was there, and that through that secretariat it is done. So they have grouped entire globe into various categories, and Asia is given number 5, and Q is given for a 5th order basin, or I don't know, first order, either given for Indus, and O is given by O is given for Brahmaputra and Ganga basin. So 5K and 5O is the first two numbers for all glaciers. Either they are in, it suggests 5Q means it is located in Asia, and Q represents Indus basin, and 5O represents Asia, and O represents the Indus and Ganga and Brahmaputra basin. So that is how, then it is further, suppose you take the Indus basin, it is further divided into sub-basin. Of course, there is a procedure to do that, but it is done. So it is now, if you have a Satluj basin, then it is grouped into two categories, one Satluj and Indus basin by Geological Survey of India. There is some ambiguity in UNESCO, but Geological Survey of India is done in that fashion. Then that is the first order, and the second order basin is, first order basin is Indus, which is a Q, and then second order basin is Indus and Satluj. So it is 5Q1 and it becomes 5Q2. Then what happens is, then you have third order basin, which is given as different names. You can see Zob, Kabul, Khurram, Indus. Then in Satluj, there are Chenab and Satluj. So if you want to see into Chenab, then Chenab is 1. So Chenab's number becomes 5 for Asia, Q for Indus, 2 for Satluj, and 1 for Chenab. So it indicates that it is a sub-basin of Satluj. That is how number. Then that is a further group into categories such as Ravi, Chenab, Kishan Ganga, and Jhelum, and Satluj in Bias and Satluj. And then there are a different sub-basin within that it is identified. So if you really want to say in Satluj basin, and if you want to have a Parvati basin or Bias basin, then it becomes like 5Q2219 is a Parvati, 5Q2218 is a Bias basin. That is how the basin identification is done. So now the number, suppose you are monitoring glacier in a Parvati basin, the suffix will be 5Q221, 9 or 09, whatever way you want to put. If you have more than that, then it is 09. So that is how first suffix will come, and then glaciers has to be then identify glaciers. There is also procedure. Uh, how do you do it? So it has to be done in a clockwise. You can't number it anti-clockwise. Generally, it is put into clockwise. So if you have the Parvati basin, then the clockwise you should start, and then it should do 1, 2, 3. So entire round will come like this. So maybe glacier 1, and if there are 124 glacier in Parvati 1, one will be northern side of Parvati basin, and 124 will be southern side. It is a complete round it will take. So that is how it is done. That is the convention. It is not necessarily followed like that. Then this inventory was originally started in 1977. You can see some of the. So the computer technique was in infancy. And because of that, there was a card system, cards were used, so that there was no, still GIS technique was not invented at that time. But why I'm elaborating this, because many of you will use this data from GSI for inventory, or that matter data from a space application center also, because SAC inventory is also using the same principle. So if you don't have a layer, which in these days it is there, and the digital DM is also there. So some of these things, whatever is given here, you can really do it automatically. So let us look into when you have this data sheet, which is to be prepared by uh, under this Glacier Inventory program, and it is available. You can download it globally also. There is the data, and in India also it is there. You can actually purchase that book from Geological Survey of India. It is very small price, but it is worth having that book as a reference material. So what essentially you do is first is regional identification number, that means it's 5Q, whatever it may be, I was explaining earlier. Then you get digital glacier number. There are 1, 2, 3, 4 slots are available. And then you get, so you can have 00, 1, 2, 3 slots, 001 you can do. And then you have your latitude, longitude. If you are using UTM coordinate system, you can give that. Then you also need to give orientation in accumulation area and orientation of ablation area. You know, the many glaciers might have different orientation, like accumulation and ablation area. And it is 8-point compass. What it means that you can only give is northeast, northwest, southeast, southwest, like that. So entire circle is put into eight points, and then you can do it according to that. So you also need to give highest glacier elevation. Remember, highest glacier elevation is a different than the peak. Peak is not the peak, mountain peak is not. So you need to have this inactive ice versus active ice. You need to delineate that boundary, or you need to some kind of adjustment you need to do and give the highest elevation. Then the lowest elevation is nothing but the terminus, and you need to give whether it is exposed or not, and total. So elevation of snow line. If you are using satellite images, then you can definitely give the elevation of snow line. Or if you it's not an issue, so you can give elevation of snow line if you have a data, because at that time, I think 1977, there was aerial photographs were available, so you can give elevation of snow line as just one, because it is predominantly done by aerial photographs. So, and the date of snow line. Why I'm telling you all these things, this will also help you to compile any work if you are doing, what kind of information you can store in it. That is very important. Then you also give the mean accumulation area elevation. It is weighted. It means what it means is that mean accumulation, there could be different ways by which you can estimate the mean accumulation area. It means you can take the highest point, lowest point, and take arithmetic mean. This is not this idea. This weighted means where the accumulation area is divided into two equal halves. That is where this is above means 11. Then there is the average rating, accuracy rating is also there. That means we will probably look into later on, but this is very subjective accuracy rating is there because there is a lot of issue in, because if you really look into any date of snow line may not give you accumulation area. And because of that, this is very subjective in a sense like 1 means very highly accurate and 5 means, I think, very low accurate, but subjective in a sense like how you feel about it rather than doing it very mathematically at that time. But now we can do far decent job than this. Then the same area, the mean ablation area is also weighted, which means where the ablation area is put into two equal halves. The maximum length ablation area you can give, and out of that, how much is the debris cover, how much is exposed, and how much is the total. That also you can give ablation area. Mean width of main ice body. So what really happens is each glacier, if it is in complex, then there will be numerous tributary glacier contributing in it. And because of that, there could be a mean width at various places, but you gave the main ice body how much is the mean width. Um, then the surface area exposed and total and accuracy rating. So you can, so it is also some way giving information about exposed surface area and how much debris cover and the total you give. So there is no need to give again how much is the debris cover because once you have exposed and total remaining remains as a debris cover. The area of ablation you can give and then AR, actually there's no need to give AR, but here it is people are asking for AR because once you know the accumulation area and ablation area, you can always calculate it. But here you give, then the mean depth because that is time when there was no idea of depth was there. So we will discuss that and the volume. And there's a classification description, we will come into that. Then there's another data sheets, which is which gives about uh, various other features. So that means even though it is glacier number, glacier everything. So key component in this number of drainage basins. What it means is glacier is it draining into one basin or two basins? Which topographical map you have used? The photography you have, if you have used, which photography you have used. Then, of course, there is punch card and other issue you can see. Then the surface area. So these are the information about various things you can use. And some of these, if you look into the last one, which is highest glacier elevation, mean glacier elevation, lowest elevation, mean elevation of the elevation information is also given there. So come on, some of these things we will see that this was Glacier Inventory way back in 1970 was prepared when Mueller was at McGill University and I was just, you know, I joined much later on there, but I had opportunity to work with him on this some of these programs in later part. So there is a various ideas, the classification about which we were talking about. Here it is, um, and then generally it is seen into one, two, three main classes. One is the valley glacier, another is the mountain glacier or cirque, or glacierates and snowfield. So, what is the glacierate and snowfields? This is something which is complex to estimate. We will probably discuss this in context of ISRO inventory. But some of these things we have to redefine if you are using satellite data. So the valley glacier, whether it is a compound basins, that means there are, if it is a large glacial complex, like say Gangotri Glacier complex, that means there are tributary glaciers, and the tributary glaciers also have more tributary glaciers. So this is a compound basin. And then if there is a just one compound, one glacier, and there are tributary glacier to that, or very simple, there's only one glacier, there are no tributary glacier. So Muller have tried to give you some number for that. So if we say, if it is area, then this could be whatever meter, 1 to 10 square kilometer area, then depth is 50. This is very probably first rudimentary estimates of how much is the glacial store water in a globe. Remember one thing, this program was written when probably first satellite was launched in 1970s, Landsat, not Landsat, some other name was there. So first satellite was launched. Predominantly, there was no idea about how much glaciers are there. The scaling methods, which is very commonly used subsequently, were not yet developed. So he is trying to give you some idea about how much is glacial store water into the on the globe. So that is the purpose of this inventory, and it was run eventually from University of Zurich. He moved from McGill to University of Zurich, and that is where this program was run. And you have a program. So if you look into classification, there is another, if you look into the data sheet, there is one more thing about the classification. So there are numerous ways they have tried to do it. So first is digit 1, which is there. If you can look into that, there are 1, 2, 3, 4, there are 6 digits are there. So first digit is the primary classification. That means whether it is a rock glacier, ice glacier, glacierate, mountain glacier, valley glacier, outlet glacier, ice caps, ice field, continental ice sheet, and uncertain, or if you don't know what it is, that is also there. So first 0 number is reserved in all categories, whether it is uncertain or miscellaneous, or you don't know what it means. Then digit 2 is about the basin type. That means whether it is compound basin, simple basin, seal, niche, crater, ice apron, group of remnant. And the third is about frontier characteristic, whether it is Piedmont Glacier, expanded foot, lobe, calving, and confluence. Then fourth category is about longitudinal profile. Fifth category is how do they get major source of source of snow, whether it is snow and drift snow, whether avalanche snow, or whether it is superimposed ice. And sixth category is about the activity of tongue. It means whether it is a retreat, whether it is significantly retreating, slight retreating, stationary, advanced, surge. Don't go into horizontal, it is just vertical, and then oscillating. So So that is how this was done, this inventory. And that inventory by Geological Survey of India is done and it is available. You can download, you can not download it, you can procure that book and use it as a reference. It is worth looking in that. There are nice maps in it and nice tabular form data is there. But it is only there for Indian part of Himalaya. It is not for entire basin. But still, if you want to do the sub-basin by study, this is very valuable document and you should have in your possession this document. One thing can definitely tell you about, because this inventory was done predominantly by using a topographic map and partially by using photographs, photograph was done in 1962 by Survey of India and GSI used those topographs, topographic, and then toposheet was used. So it can also give you idea about historical extent of glaciers. But remember, there are a lot of issues in it because predominantly Survey of India depends upon the geological survey depends on the topographic map, and many times these maps and the terminals or glaciers are not properly mapped in a toposheets. Many times, many places JSI has corrected it, but not everywhere it has been corrected. So it is quite possible that you might get the exaggerated information of glacier extent. But if you use it judiciously, it is quite possible for you to get quite important information from it. And it is worth looking into those things. But this is a caution I want to tell you. Another inventory, which is done by a Space Application Center, where I was intensely associated when I was working in SAC, and idea of this inventory is do it in Brahmaputra Basin, Ganga Basin, and Indus Basin. Probably you are aware that originally for entire Himalayas, Indian Himalaya, the inventory was done by me in 1990s by using 1980 satellite data. And from there, this program was evolved and then this program was funded by Ministry of Environment and Forest. And this inventory was done for entire these three basins. So they have different layers. Now look that this regionally, this inventory was, earlier inventory was in map form, but this inventory is in digital form. So there is a framework, there is a thematic layers, and there is a framework for that. So this inventory has various themes and layers for that glacier inventory, and these layers are like it is a Survey of India reference is there, country boundaries are there, state boundaries are there, district boundaries, taluka boundary, road, settlement, extent, settlement location, elevation, DM. These layers are there. Then in hydrological, they have drainage lines, drainage polygon, and watershed boundary. At glacier points, they are glacier boundary, glacier lines, glacier points, and elevation points of location. So in a glacier boundary, what you have is the ablation area, accumulation area, snow cover area, supraglacial lake, deglaciated valley, moraine dams, and in glacier lines, you have ice divide, transient snow line. Remember, there is a new term which is called here is a transient snow line. So what is that transient snow line? Is a snow line which is it is not at the end of summer. This is a snow line depending upon the when satellite data is acquired. If we have a satellite data for that good satellite data in month of August or in month of July, then that is you get the certain area about accumulation area, ablation area, and the snow line, which is a transient snow. So that means it is can still go up. So then there is so that is called transient snow line, which is likely to shift in future within that hydrological year. And then there is a central line. That means central line is the line which divides longitudinally glaciers into two equal halves. That is the central line. Then there's a point representing glacier terminus, moraine dam lakes, supraglacial lakes. So these are the point information available. And the elevation side, you have glacier elevation, highest elevation, lowest elevation. All that information is there in this inventory. So having said that, you have seen this picture, which suggests that there is the ablation area of glacier where ice is exposed on the surface, accumulation area where snow is exposed on the surface, moraines, which is a past extent of glaciers, which suggests, and moraine dam lakes. These are the lakes which you can form near the terminus, and they are really dammed due to the end moraine, which was there historically in the extent of glaciers was there. When you look onto the satellite images, you can also look these features very clearly. So you can see here this lake you can identify very clearly on satellite images. Snout you can identify, lateral moraines you can identify, ablation area you can identify, snow line, accumulation area, tributary glaciers, all these features. If imagery is good, there is no cloud cover, then you can very well identify this feature. When you identify these features, then you prepare a map of it. So this is how Space Application Center has prepared a map, which tells you various things, like this tells you, you can look here wherever there is a significant amount of moraines are there, then accumulation area, ablation area, and then there is a ice divide or a divide which separates one glacier from another glacier. Then the ice fields are also there, you can say, and in an inventory of ISRO, it is called a permanent ice field. So the key question is, what is the permanent ice field? Or in a UNESCO TTS, it is called glacier or ice field, whatever you can call. Probably you can call it glacier ice field also. So since there is no, what was the idea behind calling it a permanent snow field or ice field is, we cannot call it ice field because there is snow on the surface. So whether below the snow, whether there is ice or not, we do not know. Second issue is that the definition was redefined, this idea, because we have a multi-year satellite data. So any ice field or any geographical area which remains under seasonal snow for 2 consecutive years, then it is called a permanent ice field. That is the definition which is used by ISRO. So you should know what it means. It means quite different thing at different places. And because of that, and when you include that ice field into the glacial inventory, obviously you are going to have different glacier numbers because these ice fields also needs to be numbered. And because of that, you can see there's a large variation in glacier area given by different inventory and the number of glaciers given by different inventory. You have to be clarity on this aspect. So this is the overall how much it saves, So a glacier inventory, which is done by Space Application Center, gives you this consolidated outcome. That means how many sub-basins are there in Indus, Ganga, Brahmaputra basin, and how much is accumulation area, how much is the debris cover, how much is exposed, the total number of glaciers, then total glaciated areas. So you can really look into that, that if you, it is quite inflated, in this inventory that is 71,000 square kilometer area. But remember, 2 points you have to understand in this. In order to understand this inventory properly, first thing you have to understand, there is inventory of permanent snowfield is also there in it. And that is one part of story. And that permanent inventory means the snow which remains there for 2 consecutive years. That is there. And it's geographically, it is a different. Geological Survey of India's inventory is only Indian part of Himalaya. And that too, there are certain regions within the India, Aksai Chin and Pakistan occupied Kashmir, is not included into this. And because of that, their number, geographically discontinuity is there. And that is why the number is there. There are number ice field, then area under permanent snow, then number of supraglacial lake. So area of supraglacial lake, number of moraine dam and glacier lake, area of, so all that information is given. This is a dynamic in nature, that information, and it keeps on changing with time. Therefore, first of all, you need to understand how this inventory was prepared, what was the classification schemes was used in it, and what data goes into it. So the RGI inventory is a global, it is a global data set, and which is done globally to, and it is, as I said, it is a voluntary exercise, and I am also part of that voluntary exercise to prepare a database, and the data are organized into 19 large regions with the shapefile provided. So remember, it's only shapefile provided and number. So strength is one of the most comprehensive, up-to-date inventory of the world glaciers, contains approximately 1, 2, 3, 4, 5, 6,82,000 square kilometer area. And the glacier outlines can be combined with DM to give area distribution, area relation. So that is your exercise. That's not done by that. You can really do it by combining it. And the key limit lacks glacier ID and other met data provided in other inventory. So you can see, we have seen the inventory of UNESCO TTS or GSI inventory, or which is, there are a lot of metadata is there, and which is really missing in RGI inventory. You can see here the first order regions of RGI inventory, and here it is 14, is a region where India, 13, and India is there. So you can see here, within that, there are two, they have grouped into 13 and 14, and 15. There are 3 regions they have made, 13, 14, and so what is that? When you go into the IPCC's report, which was come out in 2010 or 11, something like that, and much later on than that, I think, something which is, so in that, with reference to this, there is some commentary made about the Himalayan glaciers. So these are different regions, and that is how it has been done. So you can see here, you have all comprehensive areas are covered, including, but remember one thing, it doesn't cover the area, even though it is given there in Greenland and some glaciers in Antarctica, but it is not really that sense comprehensive in covering that Greenland and Antarctica. So what are the attributes into the Rudolph Glacier inventory? You can see here their identification, RGI. Then there's also another program, is the GLIMS program, which is done by NASA. So they try to link with the GLIMS program where global land ice mapping, I think, I don't know, there is a format, different format, so you can link with that. So whether this feature can be called as a as a glacier or not, the date of outline, the end date of range, longitude, centroid, latitude of centroid, then first order regional number, second, so area, terminus, type code and name. So these are the only characteristics which are given. It doesn't give information of elevation and other things. So you need to estimate that. And it gives you some information that how much in glaciers are there. If you look into that, 13, 14, and 15, these two, how much is there Central Asia, South Asia, South Asia West, South Asia East. That is how it has been done. It is giving numbers. And beauty of this is it is layer is available. So you can download the layer for your study area, you superimpose on latest satellite images, and you can modify the layer and you can use it. Remember one thing, RGI inventory is not done by manually. It is done predominantly automatic tools are there by which it is done. But some of us who has done inventory globally, they have also submitted their layers and it is also available there. So you can download that inventory and you can work on it. That is where people are doing it more. Commonly this is used, and this is how uh, 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 that is you can see in that inventory. Then there's also GAN-DAN inventory, also the glacier area mapping for Asian high mountains. I think this inventory is done probably in, I think, Japanese work. It is done where 400. So this is done by manually. So this is not done by automatically. This is done by manually. And 453 Lancet images between 1990 and 2000 used, and glaciers are mapped uh, and inventory has been done. This is also available in digital form. You can also download it and use it for your purpose. Then also, if you really want to use any inventory, whether you use the RGI inventory or whether you use the inventory of dam or any other, there will be variation in glaciers and there will be some missing glaciers. So you can see that if you glaciers, there will be some missing glaciers. So you can relook into that inventory. But I can assure you that when you use this layer, it significantly reduces your effort to do the modification of that. The work which otherwise would have taken months and months, it can be done into the weeks. So that is the advantage of using this inventory and make use of those inventory and then you can use it. By using those base, you can calculate the glacier. If you have historical and present satellite images, you can calculate the amount of retreat and so many other parameters. But make sure that when you go for retreat estimation, one of these inventory is used as a base inventory, and that you develop the amount of retreat or loss in area. So with this, I think I will stop here of glacier inventory part. And if there are any questions,